Yeah, Bob's given us an example of how compelling serverless is as a use case when you're doing greenfield stuff, but I'm going to talk a bit more about using it in the brownfield, I guess, just in existing architectures, basically. So who am I? I'm a consultant at the moment. I go into places as an architect or tech lead. I've actually been using serverless for nearly 4 years now, which is quite unusual, I suppose. Because I started using it back in 2016. And that was a place called Yubl. Another company I'm going to talk a bit about is a company called LifeWorks that I spent just over 2 years with. They were very different experiences, but they both have some interesting lessons. Yubl, back in 2016, it was a new social networking app. I guess it was kind of like Instagram on steroids, I suppose. You could kind of you had all the usual social networking stuff, but you could put stickers on your post. You could have voting buttons, so I could, say, does red lipstick or pink lipstick look better on me, and people could vote, and that kind of stuff. And it was a cool idea for an app, but at the point I arrived, the big problem was that this company had been around for 2 years. Nothing had been released. It had no users. And as a result of this, a new CTO had come in, and he just fired 16 people, basically. So there was a massive change of the guard, and I was part of that change of the guard coming in to create a new back-end team. There was about 6 of us, and one of the guys was Jan Chue, who you may know if you've Googled anything serverless related. He's an AWS serverless hero these days, so he was in the team, and a few other very experienced engineers. So this is what the architecture looked like. It looked harmless enough. It was just a few EC2 containers. They had an Express app running in there, MongoDB as a database, and some worker processes using RabbitMQ. Nothing too scary. But then when you peeled away the covers, it was just technical mess everywhere. I put a dumpster fire there because I thought that was probably the best metaphor for it. One of the unbelievable things was that none of the features had really been implemented according to the requirements. They actually had a really good product team who had very carefully spec'd what they wanted from the app, but it's as if the previous guys had gone rogue and just done stuff. Releases were taking 30 minutes, required downtime, which was obviously completely unacceptable for an app. And it quickly became clear that this wasn't going to scale as the user base grew, which is a huge problem for a social network that wanted millions of users. That was never going to work. It was a bit of a triple facepalm. To qualify what I'm saying about features being silly in terms of implementation, I'm just going to give a couple of very quick examples. So unsurprisingly, the app had a search capability. It's a social network. But when we actually looked under the hood, it turns out this search was just doing a massive regex on MongoDB, which it just, other than a bit of rudimentary ranking, it didn't really do what we needed. If you got to about the 100,000 user mark, it just wouldn't perform at all. So this was an early example of where we just went in. We got the legacy monolith emitting some events that were pertinent to search. So, we cared about when user accounts were created. We cared if somebody changed their name because we were searching by name, first name and surname and username. And these were going onto a Kinesis stream. It's just one of the ways you can do messaging in serverless. One nice thing about Kinesis is that it will guarantee order within a shard. So if you were to shard on user ID, for example, you're going to get the messages in order for that user. We then just had a Lambda function that was updating a search index. We were using Cloud Search at the time, which is just a managed version of Solr. I noticed Bob's using Algolia. I'm using that in my current place, and I would highly recommend looking at that if you're thinking about doing search. And then we just had an API and a Lambda in front of it to call the search index. So very quickly we had something that we could easily work with that would perform, scale, and was easy to change. A slightly more complicated feature, and probably my favourite stupid implementation that I came across, was there was a suggested section in the app, which I think, again, anyone familiar with a social network will be familiar with this. It's just an area where, it's suggesting people that you might want to follow who you're not already following. Now, when we looked at this, what it was actually doing was just getting the top 30, the getting 30 people from the database by the time the records were created and that you weren't already following. So what this meant from a UX perspective was that every single user was being suggested the early employees of Yubl. That's what it actually did, because it was just, yeah, they were the first users on the system, so it was just recommending our own employees to everyone. It's just insane. But yeah, so it was implemented, but yeah, it's not obviously what product wanted. So by this stage, we'd already created a bit of an analytics pipeline. We had events going into BigQuery, which is a serverless data warehouse that in the Google Cloud. We had a couple of devs who'd used it previously, which is one of the reasons we went with that. At the time as well, AWS Athena didn't exist, so your only real option in the AWS stack was to use something like Redshift, and we didn't want to be creating our own EC2 containers, babysitting them, security patching them, creating VPCs, all this stuff. We were trying to avoid that, so we used BigQuery. One thing you can do to trigger a Lambda is effectively create a cron job, which is just a CloudWatch event with a cron expression. And we had a Lambda that was querying BigQuery to see who was trending on the platform. So it was looking at stuff like, whose posts were being liked the most, who was being followed the most, whose posts were being commented on. And there was a time decay function associated with this so that you would get new people every day. And we were just plopping those into a DynamoDB table. We then just had an API and a Lambda that was simply just reading that data out of DynamoDB. Another thing we'd started doing was, from the legacy monolith, we were emitting relationship events onto Kinesis. So we cared about when a user followed another user or unfollowed them. And we were putting those into a graph database. We used something called GrapheneDB, which is effectively a managed Neo4j. It's serverless. You don't have to, you don't have to have any servers to use it. And the reason we did this is because typically what you expect from suggestions is that these are going to be based on people you already follow or know. This enabled us to query second and third degree connections. So, say Will follows Bob, he follows me, it would suggest Bob to me as a second degree connection. You see this all the time on LinkedIn. I think they quite explicitly mark it out on there. So this is what products actually wanted. Again, we stuck an API in front of it, and what we wanted to do was immediately make this available to the users. We didn't want it just to be available to users that installed the newest version of the app, so we got the legacy API to proxy to those new APIs, and lo and behold, people were actually getting suggested non-Yubl employees for the first time. Just as a reminder, that's kind of what it looked like in April 2016. Come November, it looked more like that. So we'd very quickly built an event-driven, microservices-oriented architecture where Lambda was the centerpiece of it all, really. And there was only a handful of us doing this. Interestingly, actually, none of us had used serverless or Node as well, which is quite interesting. We were also former .NET people, hilariously, which is quite funny. In terms of numbers, we had about 170 Lambdas running. We estimated it was saving us about 95% in terms of costs because, it was a new network. We were paying for a lot of idle using EC2, and we were able to, get a lot more releases out. You also get a very generous free tier on Lambda. I think you get like 1 million requests per account per month. So early on, you're kind of getting it free to some extent. Anyone thinking, well, what was the business benefit of this? So we'd gone from nothing. The new CTO had come in. He'd shaken things up. He managed to get the app out in 7 weeks. We had 850,000 downloads, loads of monthly active users, and we actually got as high as 4th in the App Store, which I couldn't believe at the time. So things were going pretty nicely. Similar to Bob's experience, another thing it allowed us to see once we actually had users was how this would deal with spikes. I mean, we'd hypothesized that it would deal very well with them because we knew how it worked. At this point, we actually had influencers on the platform. These were influencers from other places like Instagram. So this lady, Emily, had 40,000 followers. We ran a little marketing thing with her where she gave away a free handbag, and she was like, I'm going to announce the winner at 10 p.m. or whatever it was. Yeah, it was 10 p.m. So yeah, quite similar to the marketing campaign we were seeing before, but probably to a lesser extent. Traffic was fairly low, and then boom, it was kind of 100 times spike in traffic, just as all these people came to see if they'd won the handbag. Because we'd organised this marketing campaign, we did know about it, so we'd kind of purposely ramped up the EC2 containers for the monolith, and then obviously we had to monitor it and bring them back down, but it required effort. Interestingly, very similar experience, Lambda it just worked. We didn't have to do anything. And it did make me think, this was a predictable spike, but what if it's an unpredictable spike? And we're definitely going to get those on a social network, and we're not always going to be able to pre-warm, compute, knowing that something's going to happen. So Lambda's great in this respect. So things were going really well at Yubl. It felt like we'd kind of turned things around, but then boom. Yeah, it was a real shame. An investor pulled out, and that kind of caused a chain reaction. The company still had money in the bank. If there's one thing I learned, it's that you assume at a startup it ends when it runs out of money. Things go wrong, but no, it can end at any time. So I was sat there on a Thursday, and then there was just some dudes in suits, and they were like, "It's over," and we all went to the pub. Basically, that was that. So it was ridiculous. So I still see it as a kind of success story, weirdly, because it really showed me that we could go into a place that was in a really bad way, and I would say we almost turned it around. And serverless very much helped us to focus on the business problems, a bit like we were looking at in the Matrix. We weren't messing about with generic concerns, babysitting servers, security patching them. We weren't doing any of this. We were just focusing on delivering what the product team wanted. So the next company I'm going to mention is LifeWorks. I didn't go immediately here after Yubl. It was probably 9 months after. LifeWorks were a different beast in the sense that they were actually already a successful company. I think the first all hands I went to, they were kind of had 60 million quid in revenue and 10 million of that was profit. So they were doing pretty well. But they wanted to pivot in terms of what they were doing and go towards wellness or well-being and do a lot more analytics and reporting around what they were doing. In terms of well-being, which I'm going to be talking a lot about, that's the World Health Organization definition of it, but it's not just your physical health, it's your mental health, your social health, your financial health. It's basically anything that contributes to how you're doing in general. So the problem I was brought in for, I suppose, so the CTO got in touch with me, he'd seen what we'd done at Yubl, and they were kind of in gridlock. I mean, they had this monolithic PHP application. They tried to implement some of these new wellbeing features inside this monolith, and I think a team of about 16 guys had taken 6 months to do something not that big. And that's not a reflection on them, it was just, it had got into the state of, it was very hard to work with. So I think the CTO realised there needed to be a change in direction because they'd actually signed a contract with the Royal Bank of Canada Insurance Division, and they promised a whole suite of work in a year. So they'd signed one of those contracts where you needed to deliver it in a year. But the payoff was big because this huge company was going to upsell their product with their insurance, basically. So we spoke about what Ed wanted from a new architecture, and it was the usual stuff, we wanted to deliver more business value with fewer people and everything. There was a few more unusual requirements, like right from the off, he said he wanted to geo-partition the data. And the reason for this was that the wellbeing data could be quite sensitive in nature, so we could ask questions like, do you feel suicidal? And some of our customers were very uncomfortable with that data living outside of their territory. So this was a requirement from the offset. And he kind of knew that if this took off, we probably needed the flexibility to go multi-region, because it was the kind of thing that if it did take off, it would take off big. So yeah, we decided to go serverless. It was a good fit. And when I first came in, I spoke to the front-end guys, and they just had some minor concerns, really, because they were talking to this monolith. they basically didn't want things to change that much. They didn't want a proliferation of URLs. Now we were going down the microservices route. They wanted to be able to speak to APIs in the same way that they're doing currently, so authorize in the same way, use the same kind of contracts, if they were paginated through data, for example. So I was like, yeah, fine, no problem. And I literally in the first week, I think, I'd sort of tried to crack those ones. So yeah, using Route 53 and API Gateway, we could have a single base address. I created a custom authorizer that hooked into the old backend and enabled us to easily auth endpoints so that everything was secure. And I just created some quick middleware for the REST endpoints that would enforce the conventions they were using. So anyone that's not sure what an authorizer is, it's just a special lambda that can perform authentication and authorization, and it's reusable across API gateways. So once you've got one, you can just reference it on any endpoints. So it's not like you're rewriting this stuff on every endpoint. To give you a few examples of some of the stuff we were building, we were doing stuff like health assessments, which were just quizzes to kind of see how the user was doing, their financial health, mental health, all this kind of stuff. We'd give risk scores based on their answers, and then we could actually curate content for them to consume based on what they said. So that was one of the first things we did. We started looking at improving, getting people going physically. We implemented steps challenges that it hooked into Google Fit and Apple Health Kit on your phone. You could also enable location data, so it could give you feeds saying you were running for 20 minutes in Battersea Park, and it was measuring you against the recommended 10K goal for steps. Quite quickly, we iterated on this and added Fitbit integration because people wanted to use the Fitbit wearables, so we built all that. Then they wanted it to be kind of company-wide. So admins could create a challenge for the whole company, people could join, you could form teams, and then you kind of got leaderboards and stuff to say who was winning, which team was winning, who was winning within a team. So it was quite cool in the end. And we actually used it internally as well to raise money for charity, which was decent. They tried to gamify all of this stuff, so they had a feature called tiering, and that just meant that when you did stuff in the app, you earned points. So if you did a certain amount of steps every day, you'd get points. If you consumed snackable well-being content, you get points. If you did health assessments, you get points, so on and so on. And the companies could define tiers like gold, bronze, silver with points tallies, and it would unlock rewards. Again, they could define the rewards that they wanted to give their employees for engaging with the app. So that's just a few examples of stuff we were building. And 1 year on, we'd done a heck of a lot. I mean, we had 25 microservices, again around 170 lambdas. But what was really surprising when I look back on it was we did it with about 2.5 developers on average. So at first it was just me, and then shortly after we hired Deanna, who's here today. And I'd say in the last 4 months we hired Vivian and Imran, and they helped get us over the finishing line. But it was pretty amazing how much we were able to get done with just 4 people. It wasn't just productivity gains either. We actually found some of the requirements we were given were just easier to do. They felt easier anyway. So I mentioned the custom authorizer before, and that we needed to geo-partition data. So we were able to just use that because when it authenticated a user, it knew which country they were from and which country the company they were working was from. And we were just able to bake in the business rules we were given to therefore decide, well, based on this is where data should live. And that just got passed to the downstream landers in the auth principle. And there's a little code snippet there. It was just a case of passing that region to say DynamoDB, and that's where the data would end up or get read from. Very simple. Because we wanted to do analytics and reporting quite early on, they were keen on us getting some kind of data lake up and running. Again, we didn't want to be using something like Redshift. We just didn't have the time and resources to look after all that. But around that time, AWS Athena had come out. So we were heavily using SNS for doing pub sub. And we were able to take those events and send them to kind of Kinesis fire hoses, which would then bang all the unstructured data into S3 buckets. You can then configure these things called glue crawlers, which perform ETL over the unstructured data. And what they're effectively doing is they're just looking at, say, a JSON event and figuring out a schema for that event. You can then use Athena to run SQL queries over that data. So effectively, you're just whacking some events into S3 and you can run SQL queries over it. It's very cool. And you don't really need to do anything here because the glue crawlers auto, say you add new fields to an event, the glue crawlers will auto discover them. There they are, you can query them. An hour later, they're there. And an example of Brownfield, I suppose, is that you're not necessarily going to be able to pick your BI tool. They ended up using 2 while we were there, and we could still use this because you can just expose it using an ODBC connection as a remote view, and it can hook into pretty much anything, and they can just run queries over it. One issue we had is, obviously there's 4 of us, we've now got a load of microservices, loads of lambdas, stuff can go wrong. We wanted to be more reactive, I guess, and proactive because we didn't have much time to just be looking at stuff. So one thing we did quite early on was set up a logging and monitoring service. This did stuff like enforce log retention policies in the beginning, because by default Lambda logs are set to never expire, which is really bad for GDPR and also your AWS bill. So you can hook into events if you enable CloudTrail in AWS. You can effectively hook into system events. So at the point a Lambda is created, it will say, oh, this log group got created. And you can just create a Lambda that automatically sets the retention policy on that. So you never need to do anything, basically, it just happens. And we did a similar thing with API monitoring. There's an event, a CloudTrail event that happens when an API gets created. You just have a Lambda to say, okay, stick error alarms on all the Lambdas in that API and maybe some 95 percentile latency alarms. Just do that. So I don't have to remember to do any of that when I deploy an API. At first, we just had those going, being sent to us via email, but we realized that none of us really read emails. So again, we just wrote a little Lambda that subscribed to the SNS topic and sent a Slack alert. So if anything ever did go wrong, you'd just get slacked straight away and you could go in and have a look at all the monitoring. We did a similar thing with tracing. I mean, we in no way used X-Ray to its full capability, but we just created packages that wrapped our HTTP calls and our AWS calls in just a few lines of code. It's literally the code there. That's all we wrote. And that meant that we got full traces of everything that happened. So if there was a performance issue, for example, you'd be able to see something wasn't running concurrently or this particular operation was slow. So it's extremely useful for stuff like that. So it was a very eventful first year. And it got even more eventful, to be honest, because in June we met the final deliverable, and then in July the company got acquired for $400 million. So that was pretty cool. I'd actually taken a month out, and I think 2 weeks in I found that out. I was like, cool. So when I came back a couple of weeks later, like overnight there were some new requirements. So I think this is quite interesting in that I think a lot of people who've been using serverless, they haven't necessarily had to take an established serverless architecture and bend it or do something different with it. Here we had to do that. So suddenly, we need to support 40 languages now. Oh, and guess what? Our users all used to be in London, now they're in America. And there's a whole bunch of them in Australia as well. So he's like, oh, cool, okay. And those wellbeing features we've been building, they really wanted to put those front and center in the app now, because that was one of the main reasons they acquired us. The reality was, we didn't really support many languages. All of our APIs were in London, and these new features we built were buried away, really. So the first challenge we had to take on was, this global performance, because our customers were all over the shop now. Definitely lots of them in US and Canada, and a bunch in Australia and places like that. First, we were thinking, well, do we even need to go multi-region? Is it necessary? Because by default, if you deploy an API gateway, it's edge optimized. We thought maybe, it's not so bad. Maybe it's kind of doing some clever stuff there. So we created a bit of a hello world. We deployed it in 2 formats, regional and edge optimized. And we use a tool called thousandeyes.com, which it can simulate clients being in different parts of the world, and it will give you the full latency of a request, as if someone's calling it from India or Australia or whatever. So we took the extreme example of a user in Australia, because we now had a bunch of those. So the users in Australia, because of the geo-partitioning, their data is also in Australia, but the APIs are in London. So they're going to call out to an API in London. That's going to call all the way back to the data in Australia. And you've got these huge global hops. And we found, just a hello world was kind of taking 1.2 seconds, which is not good. With the regional setup, so they were hitting an API close to them, and if the data was there, they were there. It was more like 161 milliseconds, which was far better. We did more testing than this, but we pretty quickly concluded that we needed to do something about this, and we decided to go to Canada, US, and Australia, as well as London. And we took this opportunity to move into new AWS accounts as well. If anyone's starting out with serverless, I would highly recommend you do it in a fresh set of accounts rather than bundling it in with everything else that's legacy. There's some reasons there, but it'll help you going forward. I mean, I could probably do a talk on just this, to be honest, but a quick overview. I mean, we had to start deploying regional APIs to the new accounts at the same time we were deploying edge optimized ones to the old accounts. This just meant that we had APIs in both places. So we updated our CI jobs to do that. Eventually, we then just repointed the DNS. The APIs in the new accounts were still pointing at resources in the old accounts, because we didn't want to do a big bang of moving all of our data and everything at the same time as all the APIs. So we just moved the APIs. And when you've got regional APIs, Route 53, you can just configure latency-based routing, and just by magic, it will know which API is closest to the user and route them to that one. We then had to migrate all our data and other resources. So this was like, S3 buckets, Kinesis streams, that data lake, all this kind of stuff. And we had to write some custom tooling for that. For example, to move across the DynamoDB data, it wasn't completely done for us. We had to write a few things. We had to write some S3 stuff as well. It should probably be open source, to be honest, but maybe I can speak to Ed about that. Eventually, we pointed the new APIs at the old resources, and we just deployed them one at a time, kept an eye on them. And it was fairly risk averse in a way, because we were doing it one at a time. And eventually, we were able to just tear down everything in the old accounts. What it left us with was parallelized deployments. We realized at first that, we weren't parallelizing, so the deployments were slow as hell. Now we went to 4 regions, so we made them parallel, and we were back to the times we were before. One cool thing was that the guy on our team who was doing most of this actually worked remotely in Australia. So he saw firsthand how crap this was, from a user perspective. And he made this very quick little side-by-side video of what it was like before and after. And it's quite a noticeable difference. So this made us happy, because it felt like it was actually worth all the headache. It's not running that smoothly for some reason, but I think you get the idea. Yeah, I think that's the last one. But it was noticeably faster, like the UI just very snappy after we'd gone multi-region. I'm pushing for time a bit here. How long have I got, Will?
You're all right, mate.
Yeah.
5 minutes, 10 minutes.
So another thing that happened with this acquisition was they really wanted to push these wellbeing features to the fore of the app, I suppose. And previously, they'd just been kind of hidden away, and each screen mapped to one or a couple of microservices. straight away we were now getting screens that kind of traverse many domains. They also wanted to kind of vary the presentation across between mobile and web, because web had more real estate. So we were starting to think about this kind of stuff. We had these more complicated screens, and we were thinking, well, you know, the clients could just call all the microservices they need for that screen and piece it all together. But in this particular organisation, they were supporting iOS, Android and web, and they were 3 separate teams. So there was kind of a reluctance to duplicate effort 3 times. We could have kind of created remote view models, I suppose, but it didn't feel very domain driven, and with very tightly coupling presentations to the back end. And also it wouldn't really help us with the divergence that we talked about. And another option we thought was we could just try creating a very thin GraphQL layer on top of what we'd already done. The big worry there was it was just a massive learning curve because people didn't know it that well. We actually went for GraphQL. The thinking was that if it didn't work out, we'd just stop using it. You know, it was only for this one thing in the beginning. It turns out it went pretty well. I mean, one thing, we found it was a lot less code than if we were to sort of write our own REST APIs to do this stuff. We liked the strongly typed aspects of it because we'd had troubles in the past of what fields are required on a request and response, and there might be a miscommunication and maybe something's deprecated now. You know, with GraphQL, you can just mark all this stuff and it's strongly typed. We like the idea of the apps only getting what they needed, and that certainly helped with the apps diverging as well, so we weren't chucking stuff to mobile that only web needed and stuff like that. It was around this time Amazon had their own GraphQL offering called AppSync, but it didn't really do what we needed. It was only in one of the regions that we were now in. One thing I wasn't keen on was, and I think this could still be the case, they had no way of federating the graph, so I didn't want to go to all that effort of creating microservices and then create a monolithic GraphQL. So we wanted it so that different microservices could own their own portion of the graph. And it was very heavily leaning towards AWS's security, like Cognito, which we weren't even using. We ended up using Apollo Server instead, which is probably the most popular open source GraphQL stuff out there. And that meant, yeah, we could go to all 4 regions, we could federate the graph. At the time, it was a thing called schema stitching that enabled that to happen, but they've changed it to something like Apollo Federation now. I think they've rebranded it a bit. And I think it's more kind of tech agnostic now. And we could continue using our custom authorizer and stuff like that. And it ended up looking something like this. So from the client perspective, they were calling a single GraphQL endpoint for everything. But in reality, different microservices own their own bit of the graph, which got stitched together by that. Where we just had existing stuff and we didn't want to rewrite anything, we were effectively just calling back out into the existing API to resolve types. When we did new stuff, we were writing Lambda resolvers to avoid the extra API gateway hops. One concern we had about this, it worked really well, but it did mean extra API gateway hops, and they do mean latency. I think it can mean like up to 50 milliseconds actually, which is pretty bad. So one thing we did around this time as well was to try and start utilising caching a lot more. API gateways have CloudFront, and you can cache stuff in there. We found that using the serverless framework, it was very difficult to configure, so Deanna ended up writing an open source serverless framework plugin for this, which is, it's pretty popular. I think it's got, that's an old shot, but I think it's got hundreds of thousands of downloads now. And the other quick thing I'm going to mention is we had to support 40 languages, and this was a bit worrisome. I mean, it was even right to left languages like Arabic and Hebrew and stuff like this. It turns out that's not so hard to do in the app, but that's not something I knew at the time. So first thing we did was just pick a tool for localization. Obviously, we wanted to manage all this stuff in one place, see where we were up to. We needed integration with GitHub because we had a lot of stuff in there. Also, some of the translations could be done in-house, like we'd been bought out by a French-Canadian company, they could do that, but you know, the Hebrew we had to outsource. So this enabled us to do both. It did have its limitations though. One really crazy one was you could only raise PRs against a single repo, so it kind of assumed you had one repo, which was odd. So we were able to kind of plug some of these gaps ourselves by kind of writing code on the edge of it, and the way we did that was using step functions, which are another serverless offering AWS has. So you can define workflows basically, and you can have all retries and conditionals built into these. And this was quite nice for defining how we order translations and stuff like that. You can speak to Deanna about this if you want to know more, because she knows a lot more than me. So 2 years in, we weren't just doing those things, we carried on building stuff. I think by this point we had about 260 lambdas, we had 1,000 if you think of them as multi-region, and we still just had one team of 5 people. So yeah, we got a lot done, and it was really cool that the company got bought out and it was successful. And that's it.
So you mentioned when you joined LifeWorks, they had this existing monolith. Is there a certain different approach that you need to take if you're building alongside an existing system? Were there a lot of considerations that you had to take when you were building this new serverless stuff alongside it, or could you just extend straight off the end of it?
We were quite fortunate in that although we were building alongside an existing monolith, we were building greenfield features. Yeah. So I kind of touched on that the integration was minimal really. We just kind of needed them to know about users and to authenticate and stuff. I'd say the one gotcha you should consider with serverless alongside older stacks is it's like the opposite problem that we always used to have. We always used to worry about something getting a lot of load and crashing under that load. With serverless, you need to be careful about stuff not scaling out too much. Because there was one occasion where we actually denied the service to attack our own back end because our serverless stuff scaled out to the point and we hadn't put a reserve concurrency on it, and it started smashing the old PHP back end. Well, it brought it down for a little bit, yeah. So yeah, you need to be mindful of just because your new stuff can scale out, it might be calling other stuff that can't. So you can put reserve concurrency limits on Lambda functions to help with stuff like that. One thing I really don't like is you would think by putting a concurrency limit, you're just saying, I only want this to scale out to 50, for example, concurrently. What it actually does is take that allocation out of the account-wide reserve concurrency, which is stupid, in my opinion. So if you start putting reserve concurrency on everything, you're taking it all away from the account, which I think is 1,000 by default. So you can have 1,000 concurrent lambdas on the go. It's a soft limit though, and you can get it raised. But yeah, the main problem we had, I would say, was smashing things we shouldn't smash just because we let Lambda do its thing. And yeah, you can't do that.
I've just got one generally about service, which is how do you do local development?
Yeah, it's a very different paradigm. I would say the main difference is, prior to serverless, I was mainly doing TDD, writing a lot of unit tests. I think what you find when you move over to it, that there's much more value in writing acceptance level tests that actually leverage the infrastructure. Because where you often find stuff going wrong is you've missed a permission, to access a DynamoDB table. And there is stuff you can get where you can have offline AWS and you can use all that, but you're not going to find errors in my experience. So the experience was that you would very easily be able to deploy your own dev stack and run tests against that. So you could still debug locally. Another thing we did was we parameterized the tests. So you could run against, say, a deployed API, but you could also run the same test against your local handler for that API. So that way you could step through the code locally. And we just did that with a bit of jiggery pokery in code, so instead of making a HTTP call, it actually called a module. So yeah, it didn't feel too painful. I think the only thing is, you need to get used to, if you're running it against a stack in the cloud, deploying it and then running your tests. But you can still debug, you can still do stuff like that. Another thing you can do, you can even grab events and call your function locally with that event. Say there was a problem with a particular function, you can grab what it was passed and invoke it locally and step through the code.
I noticed you mentioned you had 100 GitHub repos.
Yeah.
How did this affect you? How do you manage them, or how does it affect your productivity?
Yeah, it wasn't too problematic. I know a lot of people go down the mono repo route and do all that. I guess the main problem we had was discovery of where stuff is. You know, we just made sure everything was well tagged and we had good documentation around stuff and naming conventions. But what we often found was there were some repos that you rarely needed to touch, you know, if it was a kind of service you'd written and it was just doing its thing and never needed to be changed, you won't go near that one much. I did like the fact that, I mean, it's a microservices thing in general, it kind of reduces the cognitive load on the developer, you know, they're working on a much smaller bit of code in a smaller repo, they can quickly check it out, they can quickly get the head around the code. But yeah, maybe it would have spiraled, you know, when 100 became 1,000, then yeah, not so sure really, but I would imagine you'd probably have more teams and they would be responsible for certain things. That's probably how you'd scale it out.
Cool. Awesome stuff. Thanks very much. Cheers,
Cool.
Scott.
No worries.